Okay, what we're doing here is we've got Bridgeport mill. The cross power feeds don't work, hasn't worked since I've had it, so I'm just trying to investigate what could be wrong and what the possible issues are. So not 100% sure, but I believe that these are 6F power feeds. This is the type of control box. We've got that here. So, and what we've got inside, this is inside the main control panel. So there's the transformer, the incoming feeds, the various contactors for the motors, the cross slides and the coolant pump. And then here we have the long feed. By the way, it's not plugged in. So we have the long feed contactor, and we have the cross feed contactor, and then this is the power feed board here. So I've just been checking out, we've got 110 volts AC on the brown and the red coming into the board here, comes through to here. We were getting no contact on, this seems to be some kind of thermal overload, so I've stripped it down. Oops. So I've stripped it down to have a look inside. I'll show you some photos of that. There definitely seems to be something wrong with the internal units of this, and I'm just trying to figure out how it works. Okay, what we've got here is the contents of the switch. I want to just try and figure out how this works. So I'm just going to heat it up. I think it's some kind of bimetallic switch, and we'll see which way it goes when it gets hot. Okay, that works successfully. So now we know it disengages as it gets hot, and then this mechanism resets it closed. Okay, we've stripped the unit down, we've tested the bimetallic strip, and we can see that it, as it gets heated, it disengages. Got a little bit of confusion though, because if you look inside here, there seems to be some heating element, which possibly looks like it was connected between this terminal and this terminal, but we found parts of the element inside, so it's obviously broken. I'm not sure if that's a fused ball or that was done past, but this heating element here is actually connected to a pin, this pin here, which isn't connected to anything. So we have the incoming live on the black and it going out on the brown. So the black comes into this ball unit here. There seems to be no path for it to actually have conducted electricity. So we're a bit confused. I'm just digging a little bit further into trying to figure out what happens. You can probably see from the bimetallic strip connected this terminal to this terminal, and when it got hot it disconnects those two terminals. Oh, sorry, okay, I'm just being dense. Yep, alright, so I think that this heater was connected through to this terminal here, which was then using the bimetallic strip to connect from here through to here. So in excess current this heater would heat up, and then the bimetallic strip would pop, disconnecting these two connections. So that makes perfect sense. So yeah, so this heating circuit is busted. So what I might try and do is actually bypass this. Doesn't sound a very sensible thing to do, but I might have a look to see if I've got a fuse or something to put in its place, and we'll go from there. So something also worth pointing out with regards to the switch is, see on the back of this board here, somebody at some point in the past has repaired this trace with this cable here. see that, so that trace is basically burnt out. It's got a thick trace as well. So this kind of comes in on pin 6, which on this side of the board is the orange cable. Now I'm not 100% sure, but I think the orange cable is connected to the potentiometers on the crossfeeds. I've got various wiring diagrams off the internet, none of which actually really apply to this machine, but in this instance the orange is the potentiometer cable. What I'll probably do is strip this unit down and see if I can check those cables. At the moment I'm kind of thinking about just bypassing this switch here. The question is did this burn out when the trace burnt out, or did the fact that the trace burning out and that burning out mean that there's some faulty component on this board, which means that if I bypass this, then it could be toast. Okay, so we've stripped off the base of this unit and had a look inside. Now, not 100% sure whether this came off when we were opening it. There's not much slack on it, so I'd assume that that's the case. But interestingly, the orange cable certainly is not the one going to the potentiometer. The orange cable is feeding back out to the motor at the back there. It's probably hard to see, but this is the feed here from the motor coming in, and I'll take a picture of that, but it certainly looks like orange goes into that motor, and we just have a bit of a better look inside, see if we can work out the wiring in there. One thing I'm not sure if you can see, which we're starting to just clean it up a little bit, I'm pretty sure that that connector, the loose connector up here, came off this unit here. This has got kind of marks on it which show that the connector's been plugged to it. You probably can't see that, whereas the other unit is kind of just generally tarnished, doesn't look like it's ever had a connector plugged to it. But what surprises me, apart from kind of the general oil, is that there's actually swarf inside this unit, which I can't quite figure out how that might have got in unless it's been operated with the front panel off, because there seems to be no obvious reasons as to why swarf would have got in there. Unless there's something very seriously wrong with the gearbox, but I doubt it. Okay, so what we've got here is the changeover switches. This is the changeover lever for actuating those contactors, and then the motors come out of here. Okay, what we've done here is we had an old ceramic fuse, 5 amps. Probably not the best thing to do, but we've wired a fuse wire between those contacts. We've checked the continuity over here, between here and here, and so we've got a circuit. And what we're going to do now is fire her up and see what happens. Okay, what we've got now is we've got the 3-phase plugged in. We've got the board down there with a fuse, and we're just going to see if we can get any movement on this motor. So the long feed is cross-linked with the motor, so if the motor goes out on overload, then the feeds go out as well. So you can hear the contactor of the motor coming in. So the motor is live. I'm just about to engage the cross-feed. Okay. So, oh, hang on a minute. This right there. Let's have a quick look. Okay, there's a bit of a puff of smoke, which I didn't actually see where it came from. do a bit of investigation. This is all still live, so I'll just shut it down and see what's happened. I'll just unplug it there too. Okay, so you know, power's disconnected. Well, I don't know what the puff of smoke was. This had actually come loose, and so there wasn't a contact there. So I've redone that, and you can probably see. Sorry, it's quite a tricky one single-handedly. So well, I've got a reading between here and here. What I might do is actually stay down here and we'll liven it up and see if we can get a closer look. Obviously keeping our hands well clear. Okay, so we're about to liven it up again. We just had a quick look at the video, and the puff of smoke definitely came from this unit here. But the fuse wire didn't blow, but what we've done is just made it a little bit tighter. It was a little bit loose. We've measured and we've got continuity again. So we're going to see if we can have a look from here, and we'll liven everything up again. There's obviously something wrong with this board. This is probably not the best way to do the investigation, but hey ho. Okay, you can hear the tiny hum of the transformer now. So we'll come down here, come over to the control unit. So put the power feed on, enable the contactors, and then we're just going to knock this button down to have a look at bringing in the contactor for the long feed. Okay. Oh, okay, that's interesting. The motor's going, but there's obviously some kind of short going. Whoa! Okay, no, that's really not good. Okay, let's hit stop. Okay, not the way to test things probably. Just turn that off. Okay, so we've got it all disconnected now. The 5 amp fuse didn't actually blow, so probably a stupid assumption to put 5 amps in. But certainly this resistor, I believe it's a resistor, absolutely cooked itself. So I don't think we can do any more at the machine. What we're going to do now is take this board off and have a good look through all the components and see if we can find something wrong with it. I think we're probably flogging a dead horse, but can't help myself. Okay, so we just put it all back together, taking this board out. We'll take that up for a bit of a look upstairs. Just going to give it a quick check. We haven't damaged anything. Yep, contactor's coming in. Okay, so we haven't really lost anything. The unit is still operational. The feeds never worked anyway, so we'll see if we can get them to work. Catch you next time.